A very good afternoon to all dear students. We will discuss the concept of fluid mechanics, continuum concept, as well as properties of the fluid. The very first, hydraulics. Hydraulics means study of water at a rest or in motion, and it is based on experimental observation. Is called hydraulics. The next is fluid mechanics. It is the branch of science which deals with fluid in a motion as well as at rest by considering force or without considering force is the fluid mechanics. It is categorized into the three parts. One is hydrostatic. In a hydrostatic, the study of fluid at a rest is considered. Second is kinematics. In a kinematics, there is a study of rotation, deformation, translation of fluid, etc. And third type is dynamic. In a dynamics, we consider forces and energy causing emotion. The next is fluid concept. Fluid is a substance which can be flow when shear force is acted on it, and it continuously deforms as long as shear trace is present. The fluid may be a liquid, a gas, or a vapor. Fluid is considered as a liquid, it is considered as a gas, or it is considered as a vapor. The intermolecular forces are very weak in liquid, and further it is very weak in gases. Vapor, the temperature and pressure is nearer to the liquid state, and steam is example of vapor. Here a gas has no definite shape of its own. It takes the shape of whole container. It takes the whole volume of the container. Is called gas. The next is continuum. The homogeneous and continuous fluid. The homogeneous and continuous fluid is called a continuum. In a continuum, we consider macro nature, macro part of the fluid. Overall behavior of the fluid is considered without going at the intermolecular level. This is continuum. If change in density to density, if it is within 5%, then fluid is said to be a continuum. The next is ideal fluid. The ideal fluid is those fluid which has zero surface tension, bulk modulus infinity, which is inviscid, that is viscosity is 0. So such a fluid do not exist in nature, do not exist in nature, is called ideal fluid. The next fluid is real fluid, a fluid which has surface tension, viscosity, compressibility are called real fluid. So real fluid possesses surface tension, compressibility, viscosity, etc. So this is the some basic of fluid. Next is properties of fluid. The very first property is specific mass or mass density. It is denoted by rho. It is ratio of mass per unit volume. Mass measured in kilogram and volume measured in meter cube. So its a SI unit is kg per meter cube. Mass density. In case of liquid, when temperature increases, the density of liquid decreases. Means density of liquid inversely proportional to temperature, whereas for gas density is proportional to temperature. At 4 degrees Celsius, water density is 1000 kg per meter cube. At 15 degrees Celsius, density of mercury tera 13,600 kg per meter cube. The next property is weight density. It is denoted by W equals to weight of fluid ratio of weight of fluid to volume of fluid. The weight measured in mg, volume measured in meter cube. Volume, as we know, mass upon volume is density. So weight density W is equal to rho g. It is measured in Newton per meter cube. Again there is a weight density of liquid inversely proportional to temperature. Means temperature increases, the weight density of fluid decreases. So this is the weight density. Next is viscosity. It is denoted by mu. Viscosity. It is the resistance offered by one layer of fluid over another layer. Suppose that there is a fixed plate. This is fixed plate and there is a moving plate. The velocity of plate is u. This is small u, this is b. So rate of deformation d theta by dt equals to capital U by B. This is a stationary plate and this is a moving plate, and there is a liquid in between these two plates. When upper layer moves with velocity u, then immediate vicinity of the layer oppose that motion. So it is denoted by B. So rate of deformation is equal to u by B. U is a plate velocity, B is a distance perpendicular to its velocity. So viscosity mu is equal to, sorry, shear trace. Shear trace is proportional to d theta by dt. So shear trace proportional to du by dy. Du by dy is a velocity gradient. So tau is equal to mu du by dy. So viscosity of liquid is inversely proportional to T. As temperature increases, viscosity of liquid decreases. It is due to cohesion. In case of liquid, and in case of gas, it is directly proportional to temperature. So this is the viscosity basic. Viscosity for liquid is inversely proportional to temperature. Viscosity for gas directly proportional to temperature. So unit of viscosity, mu equal to Pascal second. Viscosity of fluid is Pascal second. Next is kinematic viscosity. Kinematic viscosity is denoted by nu, which is equal to ratio of viscosity to its density. So it is measured in meter square per second. Kinematic viscosity. Next property is vapor pressure. It is denoted by P suffix V, vapor pressure.